Hello everyone and happy Pi Day to all. Thank you for the overwhelming support yesterday. Like more than 24 views, I think, in like less than 24 hours. That was like, yeah, very good. I don't know how that happened though. So, anyways, a very happy Pi Day, and these four problems are Pi Day specials. Of course, they are. They're all from the Stanford Math Tournament. I don't really remember the exact problem sets because these are from like scattered problem sets. But yeah, you can find them, I guess, if you look hard enough. Okay, so we have our first problem here. In a place called Trolleyland, a place of trolls, they construct bridges. So we know that it's a half circle. You know, okay, this is not really a half circle, is it? Okay, that's more like it. Yeah, we know that it's a half circle for sure, right? With radius r, and r is said to be one more than the height of the trolls. Okay, and the average height of the trolls is 3. So yeah, basically first, okay, so we're told to find the total amount of total amount of material not material used, the total length of all the bridges, and of course they mean this part, right? Okay, so yeah, let's start. So first we'll calculate the average r, right? And that will be, well, 1 plus the average height. Yeah, 1 more than the average height. And well, that's easy enough. 1 plus 3 is 4. So we have our average radius, right? That's RAVE for average. So that's 4, and I think the units were feet, but yeah, the units don't really matter here, in this case at least. Okay, so yeah, our uh, our radius is 4 feet, right? So yeah, for finding the the total amount of length, first, okay, so we know that the circumference of a circle is, well, cc. That's cool. I realized that apparently. Okay, that's 2 pi r, but since we have only a half circle, so in this case our c would be pi r, simply pi r. And yeah, so, well, we have 75 trolls, so yeah, first we'll say c is pi times r. Well, what's r is 4. By r we mean r average, so yeah, 4 pi. So we have 75 trolls. So length, let's call this, oh wow, L and C look surprisingly similar apparently. Wow, L. So the length is 75 times 4 pi, if that makes sense. And 75 times 4 is 75 times 4 pi is, well, I mean, okay, you can say there's 25 times 4, that's 100, and 3, so we have 300 pi as our answer for the first one. Cool enough. And I guess I'll mention the units, feet. Yeah, great. Okay, now for a second problem today. Well, we've been given a box, a square box of side length 2, which has a string attached to one of its corner, a string of 4 units. Yeah, I'm gonna say, I think it's inches, but I'm gonna say units, right? Okay, and we've been told what is the largest area one can form using the pen without the string going through the box or breaking the string. So okay, so we can see that this is 4 and this is 2, so our pen can reach up to this point, right? The opposite vertex of the square at this point. Yep. So yeah, first, so it's going from around here to here, right? So it will form a radius, it will form a quarter circle, I guess. until extend an arc up to pi over 2 radians. uh, for pi over 2 radians, right? Of and this radius is 2, so yeah, that's nice. Then we have the string directly, so this will extend. Okay, no, that's not so good. Now this will become our pivot point, our center for our 4 centimeter circle, and it is going to spin around, going here and here and oh wait, yeah, up to here. So we have that. Now, okay, so up to here we can say that it's uh, a 3 over 2 pi, yeah, 3 pi over 2 radians. And then from here we have another arc that extends for pi over 2 radians, which is again of 2 inches. So well, we have these three sectors. This is the first one, this is the second one, and this entire thing is the third one. So well, I think that's the largest area that can be formed. So okay, let's calculate the area. Right now these two are equal, so we can just say that that's a half circle of radius 2 and the area of okay, so let's just write the formula for the area of a circle in general first, right? So we have the area of a circle is pi times r square. Now okay, the area of half a circle would be pi over 2 r squared. Well, our r is 2, so 4. So yeah, we have 2 pi inches squared. Yeah, that's okay, square inches. Okay, a for the smaller parts, and for the larger arc we have, okay, so that's a 3/4 of a circle, right? Yeah, 3/4 of a circle. So we have a equals well, not pi r square. Okay, so we have 3/4 pi r square, and now our r is 4, so we have 3 pi and then, well, 4 squared. This is all over 4, so these cancel out and we have, well, pardon me, 12 pi, right? Yep. And well, that's for the larger area. So combining those, we have the total area of our shape. So okay, so we have as plus al. This will be 2 pi plus 12 pi, and this adds up to 14 pi square inches. I don't really know how to write square inches. I don't use that unit, more of a metric guy personally, but yeah. So that's the solution for this one, and of course pi and pi because it's pi day, boy. Okay, and then we have, so now we have an integral. This is, well, I mean, it should be clear that pi is going to come up by the limits, and this is like basically the extent of my calculus. I can't do much calculus. So yeah, so well, this is theta, and with respect to theta, right? So this should be easy enough. We have a 2 pi and 0 there. So first we'll take the antiderivative of theta squared, which is, well, so you have to ask yourself what function, the integral of what function is theta squared, and that is theta cubed over 3. That is our antiderivative, and then we evaluate it from 0 to 2 pi. So yeah, that should be quite easy. So well, the lower bounds are 0, so that's just going to become 0. So we just have to calculate this one, and that is 2 pi cubed over 3. Remember to put the parentheses around these because it tends to make you lose a lot of points. Yeah, and now we have 8 pi cubed upon 3. That 3 doesn't look nice. 8 pi cubed upon, okay, that's worse. Yep, 8 pi cubed upon 3 is our result. This is right. Is the integral of 0 to 2 pi theta squared d theta. Okay, that's on frame. Nice. So that's all framed up, and that's our main answer, right? Okay, good enough, good enough. So, okay, now we have an interesting geometry problem, you know. So, we've been told that a chocolate kiss, yeah, that's a chocolate of some kind. It's a conical shape, right? So, we have, oh, sorry, but I got this wrong, yeah. In fact, it's supposed to be R is 2, so I represented the diameter somehow. Okay, so that's supposed to be 2, right? So we have the shape of a Hershey's Kisses. I think that's the company's name. That's what the chocolate is, but I'm not sure really. So yeah, so we have its radius as well. Its radius is given to be 2 inches, I think, but I'm not gonna write the units as just extraneous. We're doing math, not like physics and stuff. So yeah, our radius for the entire chocolate is and let's write r1 is 2, and h1, i.e. the height of the entire chocolate, is 4, right? And then we're told that someone takes a bite off of it, a conical bite of like 2 of 2 height. So we have h2 is, well, h2 is 2, right? And we've been told to find the volume of the remaining area of the remaining chocolate. Okay, so well, first of all, may I just remind you, the volume of a cone is a third pi r square h. It makes sense dimensionally for those physics nerds. Yeah, okay, so yeah, because it's like cube units, makes sense. And I think this is like the midpoint theorem or something for cylinder in like 3 dimensions. Not sure though, but yeah, I think it is that. That's how you derive it and stuff. Okay, moving on. So we have v of cone, and then okay. So yeah, first we'll derive the v of the entire chocolate. So v of k is short for kisses. Yeah, a third pi, r is 2 in our case, we are using r1 right now, 2 squared, and h is 4. So we get 4 times 4, that's 16 over 3 pi. Yep, that makes sense. V of yeah, v of the kisses is 16 over 3 pi, right? It makes sense. Okay, so now we move on to calculating the volume of the byte. Okay, so we can see by similar triangles that the radius of this will be 1, right? So okay, so v of, I will just write it out here. So r of r2 should be 1. For the formalities, we'll write it out. Okay, so v of say b. Okay, man, I'm running out of ink. Okay, yeah, so v of b is, okay, let's see, well, so a third pi, well, r is 1 square, and h, well, we have 2, so 2. I'll put these in brackets too, just to make things crystal clear. Okay, yeah, this should be easy enough for anyone to calculate, for that matter. So this is just 1, this is Yeah, 2/3 pi v of b. And well, now it's quite easy to see that v of vr is the volume of the entire chocolate minus the volume of yeah, what is this, the volume of the bite. Okay, and well, that's 16/3 pi minus 2/3 pi, yeah, and we get 14/3 pi as our volume of the remaining area, volume of the remaining chocolate. So hopefully you liked that sweet problem. I am funny, please subscribe. Yeah, so yeah, hopefully this was nice, and I think this is very pi day of myself. Yep, that's an adjective. Okay, so yeah, that's pretty nice. Nice.